Thank you very much for the introduction, and thanks everyone for joining this session today. I am part of the Amazon Web Services professional services team who helps customers to use blockchain on AWS. Today we're going to talk about blockchain, and I'll start a little bit of a story around the blockchain itself and what it does as a technology, just to bring everyone on the same page. And then we will talk about the AWS approach to blockchain and how AWS views the blockchain as a technology. We'll talk about the services available on AWS and that implement the digital ledger database technology. And finally, we'll see and look at some of the case studies. So first, I just want to start with an idea that the history of record keeping is coming all the way to the ancient Mesopotamia, where we found the clay plates with recorded transactions on them. And according to the historians, that those transactions are usually some sort of buy and sell transactions or ownership transactions that are recorded in those clay plates. And then through the ancient Egypt to the more modern times, this idea of record keeping was always there. And till the recent times where the IT technologies and the computers were invented, and we start using computers to record those financial and other types of historical transactions. And then we came into the conclusion that since it is much easier to change the data when the record is fully digital, we need to come up with a technology that will help us to make it immutable, at least as hard to change as in clay plate in ancient Mesopotamia, or even in a paper with a pen with a double entry accounting. And that's why blockchain came up with some of the peculiar ways of doing this and achieving this immutability and temporal evidence. So blockchain actually contains a number of key components that I just wanted to highlight. First is the distributed ledger that with a temporal evident transaction law. So there is a difference between immutability and temporal evidence. And when we talk about the blockchain, we usually imagine this sequence of blocks with hashes that are basically the unique fingerprints of the data stored within blocks. And you know that the blockchain is basically a connection of these blocks through the fingerprints of each other, so that if something is changed within the block data, the link will be broken, and we will see the evidence of that within the data structure itself. So that's why this log that we keep in the blocks is temporal evident. And immutability means that we never delete the data. So everything that comes as a recorded transaction in a block is never going to be deleted. If we need to update the record, we just create a new version of it. So we'll see an example of that a bit later. So that's the idea. The first idea is that we keep the temporal evident log of every change to our immutable ledger, an immutable journal of records. Second interesting idea that the blockchain brings into the picture is the smart contracts. And when it comes to changing the data in our journal, we can change it in a simple way just by adding the new records, but we can create some more interesting ways to change it depending on the input that we get from the user and the data that is already stored in the ledger. We can make a more complicated decision on moving the assets depending on the ownership rights, for example, that are already recorded in our ledger. So that's what smart contracts are built for. They are built for more complicated ways to change our data in the ledger. Basically, business rules that prescribe how the changes should be made. And of course, this can be done in a centralized way, but if we do it in a centralized way, then the question arises how much we trust the central party. And that was one of the important issues that the blockchain technology decided to solve through the consensus mechanism. The consensus mechanism helps us to distribute the decision-making across multiple independent parties. And in this case, we take, let's say, a smart contract and a function that someone wants to use from that smart contract, and we validate the correctness of execution of that smart contract across multiple independent parties. And consensus mechanism helps us to validate that this particular change to our ledger through that particular function of smart contract has been done correctly. Now, it's not necessarily we have to use a smart contract in some blockchain systems like Bitcoin, for example, Stellar networks. There could be no smart contract, right? And the changes are made by the prescribed rules within the core system itself. But in other systems like Ethereum or Hyperledger Fabric, smart contracts is a big thing, and we want to use the consensus mechanism in a more to facilitate more custom transactions. So, all in all, with the blockchain technologies, we can bring trust into the network of participants. We can move away from the centralized authority into the decentralized using the consensus mechanisms. But one of the things that we should be probably interesting by now is that there is a kind of complexity that is built into this decentralized approach. And well, first of all, there is a way to overcome this complexity by using the public networks, because in that case, many of the decisions on how the network has to be managed and set up is already decided by those who started those networks. So on the left-hand side, you can see examples of the public networks like Bitcoin, Ethereum, Litecoin, Ripple, etc. And in those networks, everything is open, anyone can join. And as long as they play by the rules, they can continue facilitating the transactions and share the data with others. On the right-hand side, there are examples of permissioned networks, and the technologies that are used to build those networks are Hyperledger Fabric, Corda, Hyperledger Sawtooth, some of the Ethereum-based solutions like Quorum, for example. And in those networks, the participants can decide who can join, how the transactions are going to be facilitated, how we do updates, upgrades, etc. So when it comes to AWS, the first thing that I just wanted to highlight is that the blockchain here might be evaluated in a spectrum of other options, right? We have multiple different specially built, purpose-built databases, starting from relational on the left-hand side, and all the way to the ledger databases on the right-hand side. And the reason I wanted to highlight this is when we start thinking of blockchain as a type of a database, then many questions are basically have already answered for us, because database technology has a deep history in the IT and computer science. So when we look at the blockchain from the ledger database perspective, then we can see that we still have options, right? We have options for centralized and decentralized approach. And with a centralized approach, which have certain benefits, and there are certain benefits in decentralized approach as well. So that's why we realized that since there are use cases in both centralized and decentralized approaches, we, as AWS, should have an options to run the ledger databases in both of those configurations, and customers can choose which one to use. With a centralized approach, it will be potentially cheaper and faster, but with decentralized approach, we can achieve better trust, overall trust in cross-checking, validating transactions of each other, and having a copy of the data. So that's why on AWS we provide two services. One is Amazon Quantum Ledger Database on the left-hand side. That's a centralized database, but providing the immutable ledger storage and a tamper-evident cryptographically verifiable transaction volume. And on the right-hand side is Amazon Managed Blockchain. In those, that's a managed service to run blockchain networks, either with Hyperledger Fabric or Ethereum protocol. So let's dive deeper into the Amazon Quantum Ledger database. So with Amazon Quantum Ledger database, there are basically two big problems that it's trying to solve. First of all, there is a need for immutability and auditability of the traditional databases. When we discussed in the beginning the problem of record keeping in the modern IT, we briefly spoke about the ability to change the data without leaving a trace. So even if you have a log of transactions in a traditional database, you can still theoretically go and change that log without leaving a trace. Here with Quantum Ledger database, the log has cryptographic verification built into it. So if any change to that log will be tamper evident. And building something like that with the traditional databases will be quite resource intensive. It will be a bespoke solution usually. So a bit difficult to manage and scale, especially if you need to preserve the order of transactions, total order across all the instances of your database in a distributed setup. Well, the cryptographic verification has to be built into it. So it's usually hard to verify if you don't have that feature out of the box. But so the usual approach to solving this, not the usual, but the new one that was many organizations were trying to use, is to use the blockchain as a solution to this problem. The blockchain has a bit different purpose. The blockchain, in addition to tamper evidences, has the purpose of solving the trust problem through decentralization, which adds up quite significantly, adds up on the complexity of the overall solution. So therefore, a quantum ledger database was developed, and it was developed to address those problems and provide the main capabilities that we would expect from the ledger database: the immutable storage, the cryptographically verifiable log of transactions. Plus, it's easier to manage because it's fully managed service, so that the customers don't need to take care about the backend and the number of, let's say, instances of the databases that you run. It's also quite easy to use. Again, because of its managed service, you simplify the management on the infrastructure side. But as a developer, you use more of familiar tools like SQL-like language to perform queries and store and manage documents in the format that is very similar to JSON. So Amazon Quantum Ledger Database in general supports the following architecture for the application. So on the left-hand side, there's an application data that can be submitted through a single endpoint per region. And the application data comes in as a statement in the SQL-like language, combined together into a transaction. And transactions are, like in any database, atomic. And the difference with the traditional databases is that before that transaction is applied to the current store, which we can see on top, it goes through the journal first. And we record the transaction in a block in a journal. And this journal is consistent across all the instances of quantum ledger database, because underneath the covers, it runs across at least 3 data centers, at least 3 availability zones, which is hidden from you as a user or developer. And then once the transaction is applied to this journal and this transaction order is synchronized across all the instances, then it's applied to the state database. So using the journal, we can get this cryptographic verifiability, and with storage, we can actually access and query not only the individual records themselves, but also the history of each of the individual record, because we never delete the actual data from that edge. So let me illustrate that. And so in this scenario, we want to record data about the cars, right? And we want to record a fact of ownership, that Tracy bought a car on a certain date. So first, what happens is we need to insert this record into the database. We put the statement, insert statement, send it to our server. And then that insert statement comes into the journal first, and we update the table in our current state with that particular record. So later, Tracy decides to sell that car to Ronnie, and that means that we need to update the record, right? But instead of rewriting the initial transaction, we create a new one that says that we need to update a certain record and change owner to Ronnie. So the record in the current state is updated, but the history of the previous record version is still there. And then if let's say Ronnie was not very careful and he crashed the car completely, so we need to delete that record because the car doesn't exist anymore. And we create a delete transaction or delete statement inside the transaction, which removes or basically puts the tombstone record into our journal. And we remove the record from our current state view. But the actual history is still there. We can still go back and see that Ronnie owned it before, and even before Ronnie, there was Tracy who bought it on August 3rd, 2013. So that's immutability. We never delete the data. We only create a new version on top of the existing one. And we keep track of every change in our ledger. So let's talk about that a little bit. So when we keep track of those transactions that we just went through, the insert of the car record, the update of the car record, and the delete of it, we create the fingerprint of each particular statement, which is called hash. And these hashes are not only individual for the records themselves. We use a cryptographic technique to create an immutable a way to check the integrity of the whole ledger through the digest that you can see at the bottom of the diagram. So basically, we create a tree of hashes, a tree of fingerprints that goes all the way to the digest, And this digest helps us to easily verify the integrity not only of the individual record, but also the integrity of the whole ledger at each particular point in time. So what do the immutability and verifiability brings to us? Well, first of all, it helps to reduce the risk. So when it comes to auditors and when it comes to application security or data security people, they see this tool as the way to make sure, and not only make sure, but not only trust, but also verify the integrity that the data has not been tampered. Second, improve data tracking, of course, because we never delete the data. We have the whole history of all the changes. So we can implement data lineage process quite easily using the history function within the QLDB. Auditability is basically built into the system. We can use a combination of data tracking and checking the versions, as well as going down to the level of individual transactions applied to individual record at each particular point in time, so that we can audit which particular transaction at which point in time has been applied to a certain record. And of course, reduce the implementation efforts, especially when it comes to regulatory compliance scenarios in finance, healthcare, where we need to have this feature, we have this capability, and it turns out that many customers are actually ending up building that themselves. So if using QLDB, they can actually reduce the implementation effort for that particular feature. Some of the common use cases, I already mentioned banking and finance. The others could be HR and payroll, especially like tracking changes in the individual's profile, stuff like that. Transport and logistics, to track the transportation of goods, where certain goods change in hands, and we need to make sure that we track on every change. I already used the example from the government sector, tracking the vehicle title history change. And that was one of the first use cases for QLDBs. If you decide to dive deeper into it, you will see a lot of examples built on top of this use case. And what I found personally from my experience as the blockchain architect is that many of the use cases that initially start as the idea for blockchain might end up in the centralized approach because of when we start evaluating costs of implementation. So we finish that and see if there are any questions. Okay, questions so far? So let's move on to the Amazon Managed Blockchain Service. And I already briefly mentioned the idea that the blockchain technology has been built as the way to decentralize trust, move from the centralized authority to decentralized authority, to be able to cross-check and verify every transaction that goes through the network. And that idea is basically implemented in various different protocols, and the Amazon Managed Blockchain Service implements two of them. But the main idea behind the Amazon Managed Blockchain is, again, to help customers to build and run those networks, so that instead of thinking of how to do the lower level piping, you can think of the application itself. So usually when it comes to, especially in the private blockchain space, in the public it can be a bit easier, but in the private blockchain space, there are many moving parts in those blockchain solutions. So it's quite hard to set up, scale, of course, complicated to manage. It's distributed systems in the end of the days, and it's own peculiar ways of doing things, because every transaction has to go through multiple nodes to be sure that it's validated correctly. And this all ends up with higher costs, of course. So with the Amazon managed blockchain, we are building the service that is, well, first of all, it's fully managed, so you don't need to manage the server side of things. But you still can control of the sizes of the peers and the number of peers that you need in order to facilitate your transactions. But some of the components are totally managed, like those that are responsible for arranging transactions into the blocks and making it fully consistent across all the all the independent members of the network. Well, in the Amazon managed blockchain, we have a choice of using the Hyperledger Fabric for private networks and the Ethereum protocol for public networks. So we currently don't support the Ethereum protocol for private networks. That is something that is still in development. And it is easier to scale, and it is a kind of security is built in to the Amazon managed blockchain service itself. So things like network isolation, things like the cryptographic protection of the crypto material, that is built into the service already to a certain extent. Some of the things you still need to manage by yourself when you build your own application. But when it comes to the core components and the way how these components interact with each other, those crypto materials are managed by the service itself. And some of the important thing to notice for the Hyperledger Fabric scenario specifically, the consensus algorithm is based on the same technology that the quantum ledger database is built on. So it's kind of more reliable than the traditional consensus algorithm you can get from the Hyperledger Fabric. So how the managed blockchain service works. This scenario is described in the private blockchain use case, where we need to create a network first, because in the public networks, the network is already created, network is already out there. You don't need to create it. But in the private, you need to create a network first, then invite the members into your network. And those members have to have their own AWS accounts in order to join the network. And then each of the members will add the nodes and start using those nodes to build the smart contracts, deploying them, to create your applications to interact with those smart contracts and start sharing data and execute transactions. With a public blockchain like Ethereum, we don't need to create a network. We don't need to invite members because this is already there. So all we need is just to add the node and then start developing an application. So I've already briefly mentioned these two choices, and let's speak a little bit about the differences between them. The Hyperledger Fabric network is useful when we have a finite set of known users, and we want those known users or known members of our network, which are usually independent organizations, to elevate trust. So it's usually used in the context of consortiums, where we need to automate some of the consortium business processes. It has a higher privacy capabilities, because we obviously don't share the data outside of the consortium members, as well as the permission control, because we can control who joins the network and under which conditions. We can prescribe the requirements for some organizations to join, so we have a better control of that. So the usual examples are different kinds of financial organizations, some of the supply chain scenarios we've seen there, etc. For Ethereum, since it's a public network, there's infinite number of unknown users, right? And the whole data is public, right? Everything that you write in this network becomes public. So it's good for highly distributed blockchain applications, usually targeted at different types of tokens or currencies, where you want to make sure that there is a large, well, basically many users who can benefit from it. There is a easy way to use it and transact it between the unknown number of users. So you don't know how many people want to hold your token. So therefore, you just release it and then let the users use the public network in order to benefit from your token. Another example for Ethereum network is document attestation. So here in Singapore, you probably heard of the open attestation framework and the trade trust solution built by IMD, if I'm not mistaken. And that solution basically uses Ethereum network to keep an immutable record of a fingerprint of some trade documents, like bills of lading, for example. So it becomes a single source of truth for referencing whether the document has been changed or not, and the ownership of that particular document too. So why do customers care about implementing blockchain? Well, if first of all, of course, we want to move from the centralized authority to decentralized, or sometimes in consortium scenarios, we initially built our business model around decentralization, right? So they want to keep running the business transaction in a decentralized manner. Second is by sharing the information across multiple independent parties. So we want to make sure that no matter whether a certain party is part of the network or not, we should be able to keep our data. So the difference with the traditional systems, especially centralized systems, is that everyone relies on the centralized service to provide access to the data. While here, the data is copied and every member has a copy of the data they need to have access to. So therefore, if somebody will decide to leave the network at a certain point in time, that will not affect the others. The others will still keep their data. The others will still be able to run the smart contracts. Then the third is obviously the verification of every transaction. And to verify these transactions, we need to have a single and up-to-date and accurate view of data shared across everyone. So coming back to the consortium scenarios, that's something that we want to usually see there. And the business logic between the organizations can be simplified through automation. So instead of having a kind of trust but verify scenarios through reconciliations, and especially cross-organization reconciliation processes, we can simplify that by having a shared view on the data and having shared the logic of the smart contracts, so that everyone would be able to validate the correctness of execution of every single business transaction. Common use cases are also trade finance, the efficiency of sharing documentation, either cross-border or with the consortium members. Track and trace, you probably heard of the networks that are built for, let's say, tracking the the food supply chains, or supply chains for some highly valuable goods, and implementing loyalty programs. We've seen that as well, and many others. The tricky thing is usually, as I briefly mentioned before, is we need to make sure that the use case has enough, or will benefit enough from decentralization, benefit enough to offset the costs of having a decentralized solution. Because decentralized solution means that every member have to invest and play their role, starting from the basic things like paying for their piece of the infrastructure, because they have to be independent and have to run their piece by themselves, and all the way to agree on facilitating the network governance, starting again to the business aspect of it and IT aspect of it. With IT aspect, we need to make sure that all the updates and upgrades are happening correctly and by all the members, so that no one is left behind and leaving some security loopholes, for example. Or on the business aspect of it, we also need to agree on how do we treat the legal aspects of the transactions. How do we manage disputes if they happened? How do we pay for different types of the operations in the network, whether there is a contractor who is helping to manage that, where everyone does that independently, and what are requirements and stuff like that. So there are many questions that come when we start digging into the decentralization scenario. So one of the key things for the use case for the blockchain is to dive deeper into it and understand the implications, and to make sure that it actually, the costs are acceptable. So case studies. I'll start with the, okay, so let me first check the chat before I move on to the next. Okay, no questions so far. Please feel free to put the questions into the chat. So first example is Osano. So Osano is the service that you probably used already, because it's one of those services that collects the consents on cookies on websites for compliance reasons, and they use quantum ledger database to keep track of those consents in an immutable storage, so that we can always come back and verify whether this consent was given, when it was given, under which circumstances, etc. And we just need to make sure that it never gets deleted. Next one is Sage. Sage is a fintech organization. They want to share the hash of the business transactions through QLDB. So what they do, they help the businesses to manage tax filing, some of the invoice generation, and to facilitate their business operations. And they use QLDB to store those documents so that there will be immutable track of record, not only on to check the integrity of the document, but also the actions performed on that document. So there could be multiple scenarios of using that. One of them is to basically track when the certain tax document was filed and accepted by authorities, other scenarios like that. And another one is when the invoice is shared between the business entities, and the other entity can go to the trust.sage.com and then verify the integrity of that particular invoice document that they received over, let's say, email or some other means. They can just recalculate the hash, the fingerprint of the document, and then validate against the record in the immutable ledger. The goals of their system is to reduce invoice fraud, so that we can verify that invoices that we receive through potentially insecure channels are correct and or not changed. Then we want to automate the reconciliation of the payment transactions to facilitate the payment process, automate the financial audits, and many more. Another interesting example, and that's a sample application, but the use case that is coming up quite frequently is using quantum ledger database for scenarios where we need to facilitate some sort of a financial ledger operations. So this is an example of double entry bookkeeping application built on Amazon Quantum Ledger database. It's available on GitHub, but there are also customers who are using Quantum Ledger database. Unfortunately, they are not referenceable yet, but they're using Quantum Ledger database to implement the loyalty points use cases in a centralized way, of course, as well as distributing different types of tokens or token-like entities. So Quantum Ledger database gives all the advantages with verifiability of those transactions and makes the auditability easier and cheaper to do. Next couple of scenarios are, or couple of references are built on top of Amazon managed blockchain. And one of them is quite an interesting one, is the Contour Energy. So Contour Energy is a company in the United States that performs different coal mining operations, basically, and they supply coal to across the US. And they implemented the letter of credit use case together with one of the partner banks. So they use the Amazon managed blockchain to share the letter of credit document across between Contour Energy and the bank. So the idea was to actually expand that network later on to partners of Contour Energy, so that everyone will have a single view on the letters of credit document and will be able to easily cross-check and verify. So the interesting thing about this use case is that the letters of credit can come in various different ways. They can come as initially a fully digital object, or they can be also faxed as a paper document through fax. And one of the interesting ways of this document can be interpreted is using another Amazon service called Extract, that basically extracts the data from the paper document scan and translates it into the object that can be stored in the Amazon managed blockchain. So the letter of credit process involves multiple parties. So we can see here, this should be buyer bank and seller bank, and they use who are the intermediaries and represent the buyer and the seller. And the buyer and seller and the banks can all use the Amazon managed blockchain to share a single view on the document for that helps to facilitate a particular shipment of coal between the seller and the buyer. Another interesting use case is Singapore Stock Exchange. So Singapore Stock Exchange was one of the first public references for Amazon managed blockchain back in the times when it was released. And this particular project was part of the project UBIN, facilitated by MAS here in Singapore. And the use case was around the delivery versus payment scenario, where the securities were facilitated on Amazon managed blockchains network using Hyperledger Fabric protocol, and the payment has been done through a public blockchain like Ethereum. So the team implemented the way to facilitate payment on one network and delivery on another in an atomic way. So using the special kind of implemented protocol. So with that, I just wanted to once again go through the comparison between the services. So with Amazon managed blockchain, the ownership is centralized and owned by a single trusted authority. Or while with Amazon managed blockchain, the ownership is distributed across multiple parties. So if anyone would decide to leave the network, the data will remain with the rest of the members. If anyone would decide to, let's say, change the way they do business, they have to agree first with the rest of the members before updating the logic of their smart contracts. Otherwise, they will not be able to complete those transactions because everyone else will see and catch that immediately. The needs for quantum ledger database is mostly for immutable ledger and verifiable transaction log of all the changes applied to it, so that we can easily implement data lineage process, and we basically have the full cryptographically verifiable audit trail of every change that happened. For Amazon managed blockchain, we address the need of multiple parties to transaction with each other transparently. Of course, there is a way to restrict access to the certain data so that we make sure that the particular members see only the data that they are supposed to see. But since the execution of every transaction is distributed across multiple members cross-check and verify the correctness of applying the certain business rules to the ledger before this change is actually applied. That elevates the trust across multiple members. But the kind of another side of the coin in this case is that the complexity of managing this kind of system grows. And the key benefit of quantum ledger database is that since it's a centralized database, it's fast and it's cheaper to use. It doesn't require consent of other members. It doesn't require other members to pay for their piece of the infrastructure. They can just use the API of the centralized authority to interact with the data in the ledger, to use these cryptographic capabilities and verify the integrity of the data that they see. But they just use the API. They don't need to pay for their piece of the infrastructure, peer nodes, applications, managed secrets, etc. With Amazon managed blockchain, on the contrary, we remove the intermediaries. We want to move out of the centralized idea, and we group members and facilitate transactions across multiple members who need to transact with each other. We can implement the consortium-like scenarios, and in general, can this cross organizational transactions more efficient and more trustworthy. So on the overall landscape of AWS services, we see that the Amazon managed blockchain, it's a kind of in between. It's a database. It's more like a database. It behaves like a database, and I already mentioned that it's good to think of it as a database service because it just removes many questions. But at the same time, you can run the smart contracts on it. So it's an event-driven piece in it. You can think of the smart contracts as stored procedures if you're coming from the database world. So that kind of helps to set your mind on what you can do with it. At the same time, the quantum ledger database is purely a database. There is no concept of the smart contract in it, but it's an immutable ledger, the same as the Amazon managed blockchain, but just doesn't have the smart contract piece of it. So any business logic that you want to implement, you can use other compute services to do it, starting from the traditional SU2 all the way to Lambda, Fargate, and others. So with that, I'd like to conclude this presentation and take any more questions. Are there any questions? Okay, no, not yet. Okay, so the first question is, what is the processing overhead for QLDB and Amazon managed blockchain, since it requires consent from different parties? With Amazon managed blockchain, the overhead is well, as you can imagine, is quite sufficient because we need to get the consent from multiple parties who endorse our transactions. We basically need to go to them and say, this is what I'm planning to do. Are you agree with that or not? And then they execute the logic and on their side and give you the answer whether they agree or not. Sign it or not sign it. You can do that in parallel, but well, there are other things that happen there that also slow down the transaction. So in my experience, it usually takes about 5 seconds, 3-5 seconds to move or apply the change in Amazon managed blockchain. With QLDB, it is faster because we don't need to get the consent from multiple members, so it's fully centralized. So therefore, the change is happening faster. We just need to submit the transaction with all the statements that we want to be applied. And then it's only the matter of arranging the order of all the transactions that we send at QLDB. So that happens much, much faster. Public blockchain has the testnet, which can be used to do POC and free of charge, as Amazon has the same. Yes, if you use Amazon managed blockchain for Ethereum, you can choose which network you want to join. And in addition to mainnet, there are 2 more testnets that are supported. It's Rickaby and Robston. For the private blockchain, there are 2 basically subscription. There are 2 kind of versions of the service that you can use. There is a starter plan and there is a standard plan. Starter plan is cheaper, but it has lower reliability characteristics compared to the standard plan, which is production ready. So you can save the cost in that way. For QLDB, the service itself is quite cheap, so you can experiment with it and have your deal within $10 per month easily. Is it correct to state that QLDB services is different, serves a different purpose to the Amazon managed blockchain? Yes, to a certain extent, it is correct. The Amazon managed blockchain serves the purpose of building trust across independent members. So we remove completely the central authority. With QLDB, we have to have a central authority, but we still can verify that the central authority is not changing our data somehow behind the scenes, right? So the goal for both is elevating trust and provide those capabilities like data lineage, process facilitation, as well as auditability. Just with Amazon Managed Blockchain, we elevate it even further. We add the decentralization piece into it, and we achieve a kind of higher level of trust with using it. Are there any project ideas on using Amazon Managed Blockchain for self-learning? Usually, I've seen the examples of keeping track of the certificates and achievements on blockchain, to keep the credentials. Let's say there is actually an interesting project built on top of the open attestation here in Singapore, which helps to validate digital certificates from different education institutions. So document attestation use case. This similar thing I would imagine can be applied in self-learning. So the certificates from the courses can be recorded on the blockchain, and ownership of the certificates can be validated by, say, employers when the employer comes and claims that they have a certain certificate. How is quantum principle applied? AWS Blockchain. So there's nothing to do with quantum computing. So the name Quantum Ledger Database just wants to emphasize that the database is immutable, it's undividable, right? So that's why the quantum word is used there, not because of the quantum quantum computing. But yeah, the application of quantum computing to the blockchain is probably a big topic, but mainly in the research at the moment, especially the effects of cryptography, and how it might change the way blockchain operates and which algorithms it uses, stuff like that. But so far, from what I know, the solution is just to increase the length of the keys, because quantum computers are still kind of in early stages, and it's still going to take a while for them to be able to actually break the level of protection that blockchain technology has. Okay. Looks like the list of questions is finished. Any other questions? Okay, I see there are no more questions, so I guess we can conclude the session then. And again, thank you very much for joining it. And if you would have any questions, or if you want to dive deeper into any of these topics, we will be happy to help you with that. Please reach out to myself, the organizers of this course, and I'll be happy to dive deeper into your use case and to see how the blockchain can be applied to that. Thank you very much.